Okay, let's talk about troubleshooting Windows 10, lesson 6, topic number 2, troubleshooting Windows 10. Again, this will be part theory, part just troubleshooting theory, and a little bit of specific information about Windows 10 as well. So let's get started. Let me hit the present button. Let that think, and I'm playing with my virtual machine over here, which is being a little bit odd. There we go. Okay, so I guess the first rule of troubleshooting is don't panic. We make really bad decisions when we're afraid, so the more you panic, the less effective you'll be in figuring out what's wrong. So the first step in troubleshooting is gathering information. It's a balancing act. You need to gather information. You can't suffer from analyzation paralyzation. You can't sit there and keep gathering information, and not actually try to fix the thing. So it's kind of finding that happy medium ground. So keep that in mind. Also, just be aware of confirmation bias, which is something all us humans suffer from, and that we anything that confirms our suspicions, we take it as a great piece of evidence, while anything that defeats our suspicions, we immediately dismiss as nonsense. So again, just keep that in mind as well. Part of gathering the information, particularly with Windows 10, is asking the users. The users are the ones using Windows 10. They're the ones doing things. One of the things we're going to be relying on is cause and effect. So finding out information from the users is an important part. Part of the problem is users are going to make assumptions themselves. There's going to be certain things they're not going to like about Windows. They want to blame that instead. What actually went wrong. So you have to ask deeper questions. You have to probe a little bit. Again, you're going to be on a phone. We're going to try to maintain good bedside manner. So we need to ask probing questions in a polite and professional way. Logs are another possibility if you're trying to troubleshoot. If you go and look at the event logs, which we've done before in other labs. That might help you. It's not the greatest source of information, especially because you need to set things up. But if you look at the event viewer here, we do have logs. It's going to flash a bit as resolution adjusts. But we do have some logs here that might provide a little bit of information for us, or maybe not. So anyway, there's a number of 1,400 events in here. So event viewer could possibly be helpful. You can set up subscriptions in event viewer so that you can have remote logs, remote computers send you remote logs. If you're keeping an eye on a computer, if you have an intermittent problem or anything along those ways, you can do that as well. You can save the logs to the hard drive to send to someone else. Doing investigative work, clicking on things, looking at settings. If it's a machine running slow, looking at the task manager, looking to see what programs are running in the background. Another valuable tool is the sorry, I clicked on the wrong button. Now my brain isn't working. Wow, the CPU is really busy. Another valuable tool is services. The services MMC, you can run that through system management, or you can just click on services. This WS apps is eating up a lot of memory. But services will list all your current running services. A lot of these services provide important features, important background services that will show up to the user. But these are all the running services right here. All right. Case in point, so DHCP client, if the DHCP client services are running, you won't be able to get a address through DHCP, right? Plug and play, obviously an important service, keeps a plug and play running. It looks for new things being plugged in. All right. So keep that in mind as well. All right. Subscriptions, investigative work, performance monitor is another thing you can pop open. So we've played with performance monitor to view real-time performance data, or task scheduler. Task scheduler can help you run automated tasks or check the status of current automated tasks. Services we've done, device manager as well. We've had that open up in the past. See if everything's working correctly, if you need to upgrade any drivers, that type of thing. System information tool, scans current state of the computer, reports findings. Computer management utilities, all-in-one MMC that you can use to look around a little bit. The big thing is what's changed. Again, we're at a state where it was working and now it's not working. So we live in a universe of cause and effect. We can't use magic to settle our problems. So let's investigate what changed. Near all the search is the problem hardware, software related, right? So we're going to try to categorize it to help us understand the problem. Was the problem hardware, software? Is it kernel mode? Is it user mode, right? If it's a user mode problem, well, is it Win32? Is it .NET, right? Is there a particular subsystem that we have to be worried about? Windows on Windows 64, right? Is it a Windows on Windows 64 application? And if it is, whoops, I went to look at services. I guess I closed services out. Should we look at the Windows on Windows service running, right? So again, try to help us narrow the search. Can we cause the problem repeatedly? That helps us out, right? If the problem is replicable, then we have some kind of information. We can think process-wise. Like if I do A, that means B should happen, C should happen, D should happen, E should happen, right? Well, what's going on? Why isn't E happening, right? So we can check it out from A to B to C to D, E. If it's an intermittent problem, a problem that happens randomly, you get a random blue screen of death, mouse stops working for a couple seconds, but then it kicks back in. Like some of these weird intermittent problems, that's going to generate a lot more work, okay? So again, think logically, A to B to C to D, and you're going to form a hypothesis, okay? So based off the information you gathered, you're going to form a hypothesis, all right? This hypothesis will allow you to now move forward by testing that hypothesis, right? You can try to cause the problem, check out other systems that should be affected by the same problem, right? What you're trying to do is you're trying to prove or disprove this hypothesis. You can also, bulletproof way, try a solution to test that. You know, if you think it's I'm trying to think of a scenario in the back. If you think it's NDIS that's causing a problem, go and upgrade the NDIS or change the NDIS or reinstall NDIS or restart the system. Turning it off, turning it on again often performs miracles. Because of that, we're reinitializing all the services. But try some solution to test the hypothesis. All right. Ideally, you're trying one solution at a time. Best case scenario, if you try a bunch of things and then you see if the problem still exists and it's gone, you don't know which thing fixed it, but you knew you fixed it. Worst case scenario, one of the solutions you tried, you actually did fix it, and then you undid it when you did another solution. And now you thought that one of the solutions you tried didn't work when that's actually the solution. So try one solution try at a time. Try a couple solutions. When trying a couple solutions, you must decide on doing the easiest, most likely solution. In the perfect world, it's the same one. But like reinstalling the whole operating system is a lot of work. Does it have a great chance of success? Are you willing to do that much work? Try the less likely. Why don't we just turn it off and try turning it on again real quick? And see if that fixes it, at least in the short term, right? So again, try the easy solution first, okay? Even if it has a low rate of success, we'll try the easy solution first, all right? The solution you try might not completely fix the problem, but it may change the outcome, and that's more data. That's part of the investigation work, so you try to fix. It doesn't fix the problem, but instead of getting a blue screen of death, you just get a simple error message or something, right? Okay, so we had some effect. Why would that affect it, right? Now I can help you understand. Record your efforts, so you might undo any unnecessary changes, or if it does fix it, you can remember what you did. Be very wary of a fix that cannot be undone. Again, reboots often perform miracles. This is a link to the IT crowd. Running motto for one of the characters was, "Have you tried turning it off and turning it on again?" So again, There's a good reason for that, and it's true for all operating systems. When the system shuts down, it unloads a lot of the peripheral services and subsystems out of memory, and when it boots back up, it reloads it in memory. So it really is kind of a fresh start. It does. That's why it does seemingly perform miracles. All right. When desperate, turn to Microsoft. You can do system restore. You can turn to Action Center, try some updates, talk about a shot in the dark. So I'm going to try some updates, see if it fixes or affects the problem. Finally, when you're out of things to try, call in reinforcements, Microsoft tech articles, Google searches. If you have a Microsoft support contract, call up Microsoft, or some other support contract, call in reinforcements. All right. Again, users demand reliability. It's just part of modern computing. We just expect our computers to work. I started working in the glory days of the late 90s, early 2000s of IT, when users were just happy a computer worked. Like, oh, hey, look, a computer's actually doing something. That's fantastic. Nowadays, we expect our computers to work. I should mention data execution prevention. We mentioned it in the performance tuning. I'll mention it again here. Again, it's a special extra layer of security in Windows that monitors the memory processes of Windows to ensure that there isn't any unauthorized access to parts of memory a program should not have. So just to let you know that's there. We have a thing called Reliability Monitor. We can bring up Performance Monitor and the navigation tree under Reliability and Performance. You'll see monitoring tools. You click on Reliability Monitor. It's going to show you software installs and uninstalls. Application failures should generate a message every time an application should. It doesn't always. Hardware failures, Windows failures, and miscellaneous failures. All right, in summary, gather information, form a hypothesis, test the hypothesis. If a fix cannot be found and there's no good hypothesis, then call for reinforcements. Again, pressure will be high, miracles will be expected, and do yourself a favor, underpromise and overdeliver. Always do your best to underpromise and overdeliver. Do not, whatever you do, don't do the opposite. Don't overpromise and underdeliver, right? If you tell a user, I'll have it fixed in the next couple days, and then it turns out it only took you an hour, that's a happy user. If you reverse it and tell a user it should only take you an hour to fix it, but it takes you a couple days, that's an unhappy user. So do your best to underpromise and overdeliver. All right, so keep in mind the lab for this lesson is a troubleshooting lab. There's going to be 3 files for you to download. Each file is going to have 2 problems that it will mess up in your computer or potentially mess up in your computer. It's these 3 EXEs. I wrote them in PowerShell. If they do not work for some reason, or like case in point, it's the second... Also, they're reporting, so the users complain the internet's not working, so check to see if the internet's not working. If it is working, tell me what you did to verify it is working, right? If it's not working, tell me what you thought the problem is and what you did to fix it. All right. Also, they're reporting they cannot, or as a user in the users group, save to files in the encrypted folder. Okay. So they're saying they're a user in the users group and they can't save files to the encrypted folder. Again, tell me what you did to test that. If it's fine, which it might be, if you, again, when I program this thing, I'm making base assumptions on what file names are and folder names. If there's a little bit of difference, it might not work, right? So just tell me what you did to test it, what you did to talk to the user. Again, it's a help desk ticket. Treat them as so you can close them. So close out the help desk tickets. I simply say what the user reported, what you did to either confirm or deny that, and what you did to either fix it or you told the user that it was fine and gave them some instruction. Okay, that's what I'm looking for. So that's the lab for this section. Otherwise than that, I'll talk. Well, this should be the last lecture of the semester. All right, bye.